Okay, let's look at number 6, the last problem on your review. Part A says to draw the graph of y equals the absolute value of 2x minus 1 for the domain -2 to 4. And on the same diagram, draw the graph of y equals 2x minus 1 plus 2 for the same domain. Okay, so we have an x and y axis. There's nothing specific that they ask us to point out. So we're just going to need to draw on that domain. So let's get from -2, 1, 2. There's -2. And they want us to go up to 4. So 1, 2, 3, and 4. All right. So the first thing to do is to find where our vertex is. To find the vertex, we're going to take wherever the absolute value is and set that equal to 0. So in this case, it's 2x minus 1. So 2x minus 1 equal to 0. The 1 divide by 2. X is 1/2. So our x-intercept is 1/2, 0. So we can go ahead and plot that. So our vertex is going to be right in between here. We'll get as best as we can since this is a decimal. Then we need to get our 2 endpoints. So we get endpoints by plugging the endpoints of our domain into the original function. So when we plug in -2, we have 2 times -2 minus 1. So that's going to be -4 minus 1, which is the absolute value of -5, which is a positive 5. So we need to go up to 5. So let's count that for now. 1, 2, 3, 4, and 5. And that is at -2 and 5. So there's our endpoint over there. Now we need our endpoint for +4. So we have 2 times 4 minus 1, absolute value. 2 times 4 is 8 minus 1. Absolute value of +7 is 7. So that point is going to give us 4, 7. So we're at 4. We need, this is 5. So we need to go up to 7. So we will plug that in, get our endpoint over here. And then to finish drawing the graph, we want to connect these lines. So there's that side, and there we go. Okay, so part A is done. Now let's do part B. On the same diagram, draw the graph of 2x minus 1, absolute value, and then plus 2. So remember, plus 2 means that it's shifted vertically. If you didn't remember that, it's still the same process. You're still setting the absolute value part equal to 0. And when we get that, we still get the x is 1/2. But now our vertex is not going to be at 1/2, 0. It's going to be at 1/2. Then that 2 on the outside affects our y value. If we add 2 to 0, we get 2. So now our vertex is at 1/2, 2. Same thing with the endpoints. They're also going to move up 2. But if you didn't remember that, you can just plug that in. So we have the absolute value of 2 times x minus 1 plus 2. So when we plug in our endpoints, so when we plug in -2, we'll get the absolute value. What did we get up here? We got 5 when we plugged in -2, because this was -2 times 2, which is -4 minus 1, is -5. So the absolute value of -5 plus 2, which is 5 plus 2, which is 7. So back here, our endpoint at -2 is going to be up at +7. And same thing for the endpoint at 4. When we plug in 4, we are going to have 8 minus 1, which is 7 plus 2. It's going to be 9. So this endpoint is going to be at 9. So I need to go a little bit above my graph to get all the way to 9. And draw that endpoint at 4, 9. And then I just need to connect my graph. And there are both of my graphs. On the same diagram, draw that graph. And that's it for this problem.